Hello and welcome to this Bioprocess International Ask the Expert webcast. I'm your host, Alex Nicolaitis, the webcast coordinator for Bioprocess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speaker in the question and answer window on your screen. After the presentation, we'll begin the Q&A portion and I'll ask our speaker your questions. Your questions in the Q&A window will only be visible to myself and our speaker. So thank you for joining us today. It's now my pleasure to introduce our speaker, Martin Lobadan, PhD, Process Technology Manager from Sartorius.
Okay, thank you, Alex. Welcome to our presentation about different process intensification strategies. So as a small introduction of myself. So my name is Martin Lobadan. I have a PhD in bioprocess engineering, and I'm working in the Downstream group of Sartorius, so in the separations marketing as a process technology manager. I joined Sartorius in 2021, and prior to that, I collected 12 years experience in the biopharmaceutical industry, focusing on technology and system development for continuous, intensified, end-to-end downstream processes in a single-use, closed, and highly automated manner. So what is driving us towards process intensification? What can we achieve here? So different customers aim for different drivers or have different needs to employ process intensification. So one is more interested in reduction cost of goods. Other one is more interested in footprint reduction or shortened timelines for facility build-up, increased productivity of existing facilities or processes, and another option would be to increase operational flexibility or to address sustainability aspects. So here the process intensification is a holistic framework to maximize the overall productivity of either unit operations, manufacturing processes, or the complete facility. So it can enable faster drug development, and on the process side, it can be applied in a stepwise approach or end-to-end for maximum impact. And it's not only applicable for MAPS, but also for other modalities. Process intensification can be driven with different targets here. So we can optimize or change different classes, and with this intensify the process. So we can think of the utilized consumables. So do we talk about membranes, resins, or monolith, and the cycling strategy here? We can think of changing the chemistry of the consumables. So do we talk about bind and dilute or flow-through chemistry? Do we address a fully flow-through process, not only a few steps or even precipitation? One big leverage here is the duration of a unit operation. So are we thinking in time scales of 8 hours per unit operation or 16 hours, which would reflect a two-shift system? Or are we going towards a continuous operation covering 4 days or even 4 weeks? The same is true for the process duration. So how long does the last molecule of a batch is inside the facility? So on a batch, it's normal 14 days. If you accelerate your batch, you are going down to 10 days. But if you have a more integrated process, we can talk about 4 days. Or in a perfusion mode, then it's clearly linked to the perfusion, or it's 28 days of process duration. Another also important aspect is the automation. So what kind of what strategy is the customer pursuing here? Do we talk about standard standalone systems, connected or even continuous processes with interlinked units, or even USB and DSP integration? When talking about connected or continuous processes, we have surge tanks in between, so we can optimize the tank levels and the liquid flow in and out of these tanks. So in the case of pool tanks, we have only either input flow or output flow, but in a more connected fashion, we talk about periodic and cyclic tank levels or liquid flows in and out. They could be variable in an on and off mode, or even steady state. Product contact material is also highly of interest. So is it multi-use, single-use, or hybrid solution? And what type of flexibility are you addressing regarding fast changeovers, or do you want to process parallel? Do you want to execute parallel processing of different molecules? So then close processing would be very of high importance. And yeah, scale up, scale out strategy is also interesting here. To sort all these different options into certain combinations, we defined certain levels of process intensification in the downstream area. So here, level 0 is a standard batch. It's still, or it's a state-of-the-art standalone unit operation, for example, a single column chromatography. On the level 1, we are still talking about standalone unit operations, but these are intensified now for increased individual step productivity and improved automation on the unit level. So this can be achieved, for example, by rapid cycling, multi-column chromatography, improved buffer management, or increased binding capacity. The next level of process intensification is a connected process. So here we are not only talking about individual unit operation. Here at least 2 unit operations, either standard one or intensified ones, are running simultaneously. So they're running in parallel, and the output of the first unit is immediately processed by the second unit. The software orchestration is the should have, and the search tanks connecting these unit operations most probably show a cyclic behavior in fill level and in output streams. The level 3 of process intensification would be a continuous process. So here we feature multiple unit operations totally integrated with each other and with steady flow in between them. Thus, we only have very small intermediate tanks, and software orchestration is a must-have for flow orchestration. Here we envision long runtimes and close processing. As a further increase in process intensification level is level 3.1. So here it's a fully flow-through process also with complete steady-state flow in between all unit operations. Complete steady-state flow is possible since all bind-in-the-loop steps were replaced by flow-through mode. So that means that the molecule does not stop anymore and the impurities are removed from the stream. When we're talking about process intensification, most discussion begins with chromatography. So this is because chromatography is one of the most expensive steps due to the high resin cost, especially in the capture step, and the oversizing correlated to this, especially for clinical production. It's also very time-consuming in operation as well as in preparation. The gains we see for the gains due to process intensification are CapEx savings, cost of goods savings, due to higher resin utilization by higher cycling rate and increased binding capacity. We are reducing the risk due to easier column handling by going towards smaller and pre-packed columns, or even remove the columns completely when switching towards membrane chromatography. We also see CapEx, time and footprint savings due to the simultaneous execution of unit operation and the reduced number of systems when we integrate multiple unit operations into the same system. What Sartorius offers today is the support of 3 different levels of process intensification. So we are supporting the standard, the level 0 standard standalone batch purification with the resolute Kroger single use. We are supporting level 1 intensified standalone unit operations with resolute RCC for membrane chromatography and the resolute bio-SMB for multi-column chromatography. On the level 2 area, we are offering the resolute bio-SC for connected DSP, including multi-column chromatography. Okay, let's talk about intensified chromatography. And let's start with a recap. probably for the most of you. So what's the main difference between chromatography media and membranes? So on the left-hand side, you see a resin bead, which is fairly large in diameter, but features very small pores. So that the mass transport is diffusion limited, whereas in the membranes, it's a convective-driven mass transport. The resins are more multi-use to utilize the resin across multiple the resin lifetime across multiple batches, whereas membrane can be handled as single-use or single-batch use consumables. On the columns, you need packing, whereas on the membranes, they are already installed in the housing, so no packing is needed. And the residence time for the chromatography media is 3 to 10 minutes on the far end, whereas on the membranes, it's far below 1 minute residence time, so you can process faster here. Since we are offering now also a membrane chromatography consumable for the capture step with immobilized protein A, so this enables new purification platforms, so resin-free chromatography only based on membrane chromatography. On the bind and elute step, we are offering the rapid cycling chromatography, and this offers a reduction of chromatography volume and supports the lifetime capacity utilization within one batch, resulting in reduced cost of goods and a very high productivity. On the flow-through, for example, with cation exchange, anion exchange, or hydrophobic interaction chromatography for the polishing steps, this also this also supports short purification times, so reduces time on the floor, reduces buffer consumption, correlated to reduced cost of goods and the high productivity. Why should you go for rapid cycling chromatography? As I said, so this supports time savings on the floor, less preparation, avoid packing or column requalification after storage. You have short consumable, small consumable, supports footprint reduction, cost reduction due to one batch, one membrane approach, and it also supports controlled quality. And it eliminates risk like bioburden after column storage or bed instability during storage and coating changes. How does this membrane works? So it's a convective membrane. It's not a typo, it's really written that way. So it's a mainly convective membrane with a small diffusion layer on top on the surface, so that we still get a very high binding capacity for a membrane, which is, shows good binding capacities. We have a scalable product portfolio on the consumable side, and we also have a system which supports membrane chromatography. And here also Simca Online can be connected for online data analysis. How does such a cycle work? In the end, it's a normal protein A. So it's a normal capture cycle with equilibration, binding, washing, elution, and regeneration. The cycle is quite fast, so below 10-minute cycle time, and a batch can be purified within 30 to 150 cycles per batch. How does it look like when we do some number crunching? For example, 2,000 liter fat batch at 5 grams a liter, purified with a standard protein A resin. So here we assume 56 liters of packed resin. You need a chrom system with roughly 850 liters per hour flow rate. This volume can be captured within 4 cycles, within 14 hours, and this is our 100% reference cost. In case you want to be faster, then you go to membrane chromatography with 7.2 liters in the fairly high flow rate of 4.3 cubic meters per hour. You recycle it 35 cycles, but you're done with it in less than 8 hours, and you keep your costs constant. So here you're faster in case you have protein instabilities in the harvest, instabilities in the harvest. On the other hand, you can go towards cost reduction. Then you use less membrane, less flow rate, you cycle more often, and you get it done in roughly the same time frame, so 15 hours, but you reduce your cost by 40%. So these are the two options you can use to optimize your process depending on your main driver prioritization. On the other hand, we also offer not only membrane chromatography for capture, but also multi-column chromatography systems like the BioSMB system. So we offer it in 3 different scales. So the PD scale up to 6 liters an hour, or the 380 or 350 with 80 or 350 liters per hour. And it should be highlighted here that the 350 liters is per pump, and each system features 7 pumps. So fairly high flow rate, and different steps in a purification cycle are executed simultaneously. So as I said, it's a scalable multi-column chromatography unit. It's suitable especially for capture of the fusion harvest, but can also be employed for batch harvest. It features a very high resin utilization. I will say more on the next slide on that. So it's reduced cost of goods due to the resin savings. Fully aseptic flow kits are available, so no need for CIP or SIP, but still we have a very low contamination risk. And also control software with data analysis available. So this unit supports resin savings, a higher productivity, 3 to 5-fold. You can also operate the unit that you have 1 column set per batch, and so with small column volumes, you utilize the resin lifetime within 1 batch, and it's scalable. Okay, so how does this efficiency gain function actually? So we have 2 gains. The first one is the efficiency gain 1 is that you can safely overload your columns. So in the batch process shown here on the most left column, you have at the top of the column you have an overloaded resin, but at the bottom you have unused capacity to ensure that no product is flowing through the column and to avoid product loss. On the right side, you see that here the first column, we have 2 columns in a row, and the first column is safely overloaded, and the breakthrough is captured by the next column. So here we're utilizing a much higher binding capacity without losing any product. The efficiency gain 2 is that we split these columns into several smaller columns, and that we get rid of the idle zone. So no resin here is waiting until something is finished, but all columns are permanently loaded, overloaded, washed, or eluted or regenerated. And with introducing multiple columns, the columns can be made smaller and recycled much more often. So that in the end, we are saving up to 70% of the resin, due to the fact that we have very high operating binding capacity combined with a very high cycle number. And this results in a very high resin utilization. As in comparison, again, our 2 systems which are supporting either rapid cycling or multi-column chromatography. On the left-hand side, you see the Chrome system for membrane chromatography, the Resolute RCC. It's a high productivity operation system. It supported increased consumable cycling and short cycle time combined with high yields due to the consumables. On the right-hand side, you see the multi-column chromatography unit Resolute BioSMB. It features maximized operating binding capacities due to the overloading effect, increased resin cycling, and thus high resin utilization. And it has a high flexibility to allow simultaneous operation on either 1 column or on up to 8 columns. And you can operate this system with overloading or without overloading. So you can also execute a parallel batch on that system. Okay, so here the common goal on both systems is to increase the consumable utilization through productivity and cycling. On the level now, I want to show you a product which is supporting the level 2 process intensification, so connecting multiple unit operations into a single system. And this is our BioSC unit. So this is shown here on the left-hand side. You have the control module with the software, and you can, in a flexible way, connect process modules to that system. So the BioSC is a multi-step process system, and it can be configured in a batch or in a multi-column configuration or in a combination of multi-column and batch unit operations. The system can support three chromatographic steps and up to 6 columns in total. So for example, we can do capture chromatography with 2 or 3 columns, then environment activation, and then anion exchanger. So here, to picture that out, this is the most simple configuration. Here we have the control module and the batch module, where this, so to say, it's a level 0 configuration, where we have one chromatographic batch step, but already employing buffer preparation, so improved buffer management. The next configuration would be the multi-column chromatography, here shown with 2 columns, and you can do a parallel batch multi-column capture step with overloading if you employ 3 columns, for example. Buffer preparation is supported. You can also do virus inactivation, and as I said, you can operate here 2 to 6 columns in parallel. And the combination of MCC and batch processing is the connected or the multi-step processing, the connected process here shown with the control module connected to 2 multi-column chromatography modules, which are featuring the capture step combined with viral activation, and 2 batch modules for polishing operation. Okay, to sum up, Sartorius can use support in process intensification on all 3 levels: level 0 for batch, level 1 for intensified via RCC or multi-column chromatography, or even for level 2 by connecting multiple unit operations into the same system. Okay, with this, I would like to thank you, and I'm looking forward for your questions.
Okay, great. And as a reminder to our audience, you can go ahead and type in your questions for Martin now. So our first question is, do you know if process intensification has been implemented successfully in downstream operations, example use of multi-columns? Based on a paper published by the US FDA, most of process intensification are related to perfusion.
Yes, several companies are looking into drug substance, or downstream or drug substance operations. Yes, that's also true. So regarding the perfusion and most activities, multi-column capture is the best feasible for perfusion, because you have long operation times, low titers, which also reduces the number of columns. But we also have customers who are looking into, they are also interested in fast processing of a batch harvest. And here, due to the higher titer, you need more columns, makes it a little bit more complex, but not so much. But to be honest, here too, I think the first product approved by FDA with multi-column is still missing. So this is still in point which needs to be addressed in the future.
Okay, and what would be the possible capture column solution for level 3.1? It would be hard to run capture column in flow-through mode.
Yes, with PackBed, it's hard to capture that way, so to say. Maybe you need to employ some filtration or precipitation steps where you precipitate your impurities. So that, I mean, for the level 3.1, to be clear here, then you don't have a capture step like it is today. So it's a big change in the chemistry. Since you don't want to stop your product, you only want to get rid of the impurities.
And does flow-through mode operation compared to bind and elute increase the size of the product pool?
So to say, yes, because you are missing this concentration effect of the bind and elute mode. But in a connected or continuous mode, you don't collect your pools. So that means you still only need a very small surge tank, and you have the constant input and constant output flow, and you only need the surge tanks for flow homogenization. And if your complete output of the first unit operation, so let's say, even if it's a flow-through mode, and you don't need to collect it, you just have a faster pump rate, but you never collect the whole pool and in one location.
All right, thank you. And our next question is, do you see acoustic cell handling technology for concentration and washing beneficial compared to centrifuges in automated therapy production?
Let me think about it. Yeah, it could be, yes. So it's if you have an acoustic cell separation unit, I mean, here you also have some concentration. And so it would be possible, yes. But I think it's very, very product specific. What type of cells do you want to purify? Do you need to concentrate or not? So in the centrifuge, you can concentrate. An acoustic wave separator, not so much. So it depends. Yeah, can't give a clear answer, unfortunately.
And can we use both membrane and resin columns on these units?
Yes, for sure. The BioSMB also works with membranes. We already run it in parallel mode. We are currently working on overloading the resins, and the RCC. I mean, the RCC system was specifically designed for membranes, but you can also run a column on that system. Or maybe you mean the BioSC probably. You can also run the membranes on the BioSC. So this is the system hardware is independent from the consumables and vice versa.
All right, well, it looks like we're running a bit short on time, so if we don't get to your question, we'll be passing them along to Martin, who can follow up with you directly. So please go ahead and continue to type in any questions you have, and we'll get those passed along. The last question for the webcast is, did you use connected processing also for AAV purification, where we have very large harvest volumes to be reduced to very small polishing volumes?
So currently, map production is our front runner for connected processing, but we are also looking into different modalities. So here, as soon as you have very large harvest volumes, you can also apply connected processing. So would be possible, yes.
All right, fantastic. Well, thank you so much, Martin.
Thank you. Thank you too. It was my pleasure.
And thank you to our audience for joining us. The recorded version of this webcast will be available for on-demand viewing on our website, and as a registered attendee, you will receive a follow-up email providing you with the direct link. We look forward to having you join us at future Bioprocess International Ask the Expert webcasts. Look for those announcements in your inbox. Goodbye.